Let's look at some key terminology when we are graphing linear equations. So the first one, two non-vertical lines are parallel if they have the same slope and different y-intercepts. Two non-vertical lines are perpendicular if the product of their slopes is -1. Parallel vertical lines have equations x equals p and x equals q, where p and q are not the same. If one equation in a pair of perpendicular lines is vertical, then the other is horizontal. The x-intercept occurs where a graph crosses the x-axis. The y-intercept occurs where a graph crosses the y-axis. The slope of a horizontal line is 0, and the slope of a vertical line is not defined. So some of these terms should be familiar, but we haven't talked about parallel and perpendicular before, so we will discuss that in this lesson. So let's start off by graphing, finding the intercepts. It says find the intercepts and then graph. So when it talks about intercepts, the easiest way to think of intercepts is where it crosses an axis. And when you're crossing an axis, the number 0 involved. So if I'm going to find intercepts, I like to make a tiny t-table, and I'm going to plug in 0 for x. Now when I do this, this is going to give me a y, or a y-intercept. So if I plug in 0 for x, I get 0 plus 2y equals 4, which is 2y equals 4. Divide both sides by 2, and y equals 2. So when I plug in 0, I get 2. And because when I graph that, 0, 2, that is on the y-axis, so that is a y-intercept. Now to find the x-intercept, I'm going to plug in a 0 for y and do the same thing. So I'm going to have x plus 2 times 0 equals 4. 2 times 0 is 0, so x plus 0 equals 4, which means x equals 4. So when I plug in 0 for y, I get 4 for x. So when I graph this, that's 4, 0. That is on my x-axis. And now I graph my line. And it goes through my points. Remember, the points just act as a guideline, and this is a line, so you do want to put your arrows on either end. So this is graphing using intercepts. We have a lot of different ways for graphing. You can graph by point plotting, which we've done before. You can graph using intercepts, which works well if your x and y are on the same side. And then we're going to also look at graphing using slope-intercept form. So before we do that, let's do another one. Again, we're going to find our intercepts. So I'm going to plug in 0 for x. So when I do that, I get 3y minus 3 equals 0. I'm going to have to add 3 to both sides. That's going to give me 3y equals 3. Divide by 3, so y is 1. If I plug in 0 for y, I've kind of run out of room here. We'll go up here. 3 times 0 minus 3 equals x. 3 times 0 is 0, so that leaves me just -3 equals x. So here's my 2 points, 0, 1, which would be on my y-axis, and -3, 0. which is on my x-axis. And now I'm going to draw my line through my points, and then I need to put arrows on the ends to indicate that it is a line because it goes on forever and ever. Now we're going to graph a different way using slope and y-intercept. So this equation, we could actually do intercepts like we did a minute ago, plugging in zeros and finding values, but this time they want us to use slope and y-intercept. So recall that slope-intercept is y equals mx plus b. This is the standard form for slope-intercept. So this equation is not in that form. So the first thing I'm going to have to do is rewrite or manipulate my equation into slope-intercept form. That way I can see the slope and the intercept. Right now I don't know what they are because it's not in the proper form. So I got to get y by itself, so I'm going to move my x term. I'm moving the whole term, so I'm going to subtract 4x from both sides. That's going to leave me 2y equals my x term, which is minus 4x, plus my constant, or my number. Finally, I'm going to have to divide everything by 2 to get y by itself. So it's going to leave me with y equals negative 4x divided by 2 would be negative 2x, and 8 divided by 2 is 4. So now that I'm in the proper form, I can identify my key pieces of information. So the first thing I'm going to do is I'm going to use my y-intercept. Since my y-intercept is 4, that means I cross the y-axis at positive 4. So y-axis, positive 4. Now I'm going to use my slope. Now my slope is negative 2. Recall that slope is rise over run. So my slope is negative 2 over 1, which tells me I have to go down 2, because it's a negative, and right 1 from the point that I just graphed. Not from the origin, it's from the point we just graphed. So from my point, I'm going to go down 2, so down 2, and then right 1. And that's going to give me my line. Oop, that was not a very good line. Let me try that one again. And that's a little bit better. Put my arrows on the end. And there's my equation. I used the slope and the y-intercept to graph that. You have to start with your intercept because that's a location on the graph, and then you use your slope to find another point on the graph. Your slope describes the line. It's not an actual location. It's not a point on the graph, but we use it to find another point. So let's look at these two. These are a little bit different. The last problem had actually the last few problems had x's and y's in them. If you look at 17 here, there's only a y, there's not an x. So what we're going to do is when you see a single variable, that means it's either a horizontal line or a vertical line. The way you know which is looking at your equation, and so I'm going to take my 2y equals negative 5, and I'm going to get that variable by itself. So I'm going to divide both sides by 2. So I get y equals negative 5 halves, which is the same thing as negative 2.5. Since I'm graphing, it's easier to think of it in terms of a mixed number instead of an improper fraction. Since there's only a single variable, what this tells me is I'm either a horizontal line or a vertical line. And the way I know which is if I'm y equals, then I must cross the y-axis. So my y-axis is my vertical axis, and I have a y-intercept of negative 2.5. I'm going to try to guesstimate that. Pretty close. And then it's going to be a horizontal line through negative 2.5. If it's a y equals, then it must have a y-intercept, therefore it crosses the y-axis, which means when you see a single variable and it's y, all y equals are going to be horizontal lines. And while we're talking about horizontal lines, recall that all horizontal lines have a slope of 0. So if it's y equals, and there's no x, it's going to be a horizontal line with a y-intercept of whatever number you end up with, and then the slope is always 0. So let's look at this equation down here on the bottom. We have 3x minus 15 equals 0. So again, there's only a single variable, so I'm going to solve for it. Divide by 3, and I get x equals 5. So now what this means is I'm going to have an x-intercept, which means it has to cross the x-intercept at 5. Well, my x-axis at 5. My x-axis is my horizontal, and 5 is right there. So now, when I go to graph, again, remember, if it's a single variable, it's either horizontal or vertical. This has to cross the x-axis at 5, which means I have to have a vertical line, not giving me a line. Let's see if I can draw one in here. At 5. That's close, but you get the idea. It's a vertical line. Put your arrows on the ends, and there you go. So when you have x equals, that's going to be a vertical line, and the slope of these lines is what we say not defined. If you have two variables, if you have an x and a y, it's going to be a slant line. So, but vertical and horizontal lines only have a single variable in their equations. Now let's look at a different type of problem. So instead of graphing, we're given two lines, x minus y equals 7 and y equals x plus 3. And it wants to know if the graphs are parallel. You don't have to graph in order to decide whether or not they are parallel. Parallel lines have the same slope, so that's the most important thing to remember, is parallel lines have the same slope. So if you look at two equations and you can identify the slope and the slopes are the same, you don't have to graph them. You already know that the lines are going to be parallel because they have the same exact slope. So for this particular problem, one of our equations is x minus y equals 7. That is definitely not in slope-intercept form. And the other one is y equals x plus 3. Remember, slope-intercept form is y equals mx plus b. So the second one is definitely in slope-intercept form. So on this equation, my slope is 1. So if my slope is also 1 in my other equation, then they're going to be parallel lines. So in order to decide that, we have to put it into slope-intercept form. So I've got to move my x term, which leaves me negative y, negative x plus 7. Now I have to divide everything by negative 1. That gives me y equals x minus 7. According to this, my slope is 1. So since my slopes are the same, That means these two lines, if I were to graph them, are parallel lines. So yes, they are parallel. Now the other types of lines that we're going to talk about in this lesson are perpendicular lines. So we would have a similar process. Now parallel lines have the same slope. Perpendicular lines I like to say slopes are negative reciprocals of one another. So for this particular problem, we have our first equation is y equals 5 minus 2x. Just a little tweak, and this isn't the proper form or slope-intercept form. All I'm doing is moving my x term first. It's easier to identify my slope. My slope is negative 2. My other equation is 2y plus x equals 1. Now if my slopes are the same, then they're parallel. If my slopes are negative reciprocals of one another, then they're perpendicular. Now a negative reciprocal means to flip the numerator and denominator and then take the opposite sign. So a negative reciprocal to negative 2 would be a positive 1 over 2, or a positive 1/2. So when I finish manipulating this second equation, if my slope is a positive 1/2, then these lines will be negative, or will be perpendicular to one another if we were to graph them. So I end up with y equals, I have negative x over 2, which is negative 1/2 x plus 1/2. So my slope is negative 1/2. So if I compare my slopes of negative 1/2 and negative 2, they are not negative reciprocals of one another. They are reciprocals, but not negative reciprocals, which means they are not going to be perpendicular. So not perpendicular. One would have to be positive and one would have to be negative in order for them to be perpendicular lines.